So today I'm going to explain the fourth problem of Leetcode Weekly Contest 288, which is maximum total beauty of the garden. So we are given in gardens where each garden has flowers and number of flowers. We can additionally plan new flowers, number of flower to any of the gardens. Now at the end our total score will be calculated the sum of complete gardens into full. A garden is complete if the garden contains more than target number of flowers. Target will also be given to us, and plus minimum number of flowers in incomplete garden. So any incomplete garden means it does not have target number of flowers, it has less than equal to less than target number of flowers. So minimum number of flowers in any incomplete garden multiplied by partial, so partial will also be given to us. Okay, now let us see the example. So 2453 is given to us. Now what will be our first observation is that if we want to complete, like want to fill any garden first, let's say our target value is what, our target value is in this case 5. So new flowers is 10, new flowers is 10, target is target, and this is full, and this is partial, and what is given to us, this is 10 5 to 6, 10 5 2 6. So what is our first observation? The first observation I can make is that if I try to fill any garden to target number of flowers, I will try to fill all the gardens which has maximum number of flowers. So I will first sort all the gardens according to the number of flowers, 2 3 4 5. Now if I try to fill the first garden, it is already filled because it has 5 number of flowers. Now this garden is less than 5 number of flowers. Second observation is that we don't need to fill any garden greater than equals to target number of flowers, so we'll add one flower to it, so it will become 5. Now our new flower become 9. Okay, now I can also fill this garden, I can also fill this garden to 2 by 2 flowers, so it will be 5 and our new flowers will be 7. And we can also fill this garden to 5 and our new flowers will be 4. So our answer will be number of complete gardens, which is 4, into full, which is 2. So this is not the optimal answer because partial is greater than equal to full. Partial is greater than full. We can do this following approach. We can make this 2 3 4 5, we can make this all by 4. So by adding 2 flowers to it, adding 1 flower to it, and adding 0 flowers to it, 4 4 4 5. So number of complete garden is 1, so it will be 1 into 2, and maximum number minimum number of flowers in incomplete garden is 3. So our answer will be 4 into 6. So I think answer will be 26, I guess. So I think there is another more optimal answer is that uh, I can fill 3 garden. Okay, I can fill 3 garden. So I can fill this garden to 5 and this garden to also 5. So the number of complete garden is 3. 3 into 2 plus 4 into 6. Okay, so answer will be 30. So what is my approach? Is that my approach is that I can fix the number of full gardens. So let's say 2, 3, 4, 5. If my number of full gardens is, let's say, 1, so I will try to fill this garden first. So the minimum number of flowers required to fill this garden is 0. Now I will try to fill this garden to like a minimum number of flowers. Okay, so I will try to iterate on the number of flowers. Let's say minimum number of flowers. So there are 3 gardens here, and we can add 4 flowers to each 3 of the garden. Okay, we can have. Okay, so the minimum number of flowers required will be 4 minus 2, which is 2, 4 minus 3 1, and 4 minus 4 is 0. So this is possible. Now if I try to the the minimum number of flowers in these 3 gardens will be target minus 1, because if we have target number of flowers in any of the garden, then our answer is not possible, because this will be, any of this will be partial full garden then. So what I am trying to say is that let's say another example, 2 3 4 and 8, and target is also 8. Okay, now let's say our the number of flowers we can plant is 5. Now we can also if we try to make all the flowers to 5, the number of required flowers will be 5 minus 2 3, 5 minus 3 2, and 5 minus 4 1. So this is possible because the number of flowers we have, this is not possible because the number of flowers we'll have is 8. So this is possible, so we can make all these 3 gardens 5 5 5. Now let us take we can make this 6 or not. So for making it 6, it will require 6 minus 2 4, 6 minus 3 3, and 6 minus 4 2. No, 9 number of flowers, so this is not possible. So what I am trying to do is that I am trying to maximize the minimum number of flowers in this 3 garden. So this is possible by linearly iterating on the number of flowers and checking that if the number of flowers is possible or not. So we can iterate from minimum number of flowers in this 3 garden to our target minus 1, because any 3 garden will have greater than equals to minimum number of flowers. So we can try to iterate from minimum number of flowers and target minus 1. I have already told if that if the number of flowers in any of the garden is greater than equals to greater than target minus 1, then the garden will become full. So this will not be possible. So you can do it. You can iterate on minimum number of flowers to target minus 1 and check we can make all the flowers in these gardens greater than equals to that I or not. We can iterate from for I equals to minimum number of flowers to target minus 1 and check if it is possible or not. If it is possible, then what can I do? The answer will be uh, uh, I into partial plus number of complete garden into full. This will be our answer. So this will be like order of I think order of 10 to the power 10 approach, order of new flowers number of approach. So what order of target number of target approach. So what is the another thing we can do to speed up this? We can binary search on the value. Okay, so I will show you my code now, how I have binary search on the value. Okay, so first let's see here. I will try to first calculate on the suffix value. Okay, so let me explain you that first. So let's say I have sorted the values, let's say 2 4 3 5. So let's say I have chosen the number of full gardens to 3. Now minimum number of flowers required to fill all these gardens to full will be the sum of the suffix sum and target minus number of complete garden, into number of complete garden, I mean here it will be 3 minus suffix sum. Now here another thing is to observe is that if any of the garden has greater than target number of flowers, that is unnecessary. So we can make all the flowers which is greater than target to target. Okay, here so I am doing is for calculating the suffix sum I am taking the minimum value of target and ai. Okay, then I am calculating the suffix sum. Okay, here now when I get let me explain it again. For the suffix sum part, so our answer will be suffix sum, now number of complete gardens into target minus suffix sum. Okay, this is the number of flowers required to fill the C number of gardens. Okay, so after doing this operation, like after filling all the C gardens, the required number of flowers, so initially we have nf number of flowers, nf number of flowers. So after doing this operation, let's say this is p equals to, so our number of flowers now will become nf minus p. So I have to try to fill the other n minus c gardens to any of the, I have to maximize the minimum value of this n minus c garden with p flowers. Okay, I think you have understood what I am trying to say. Now this part comes when we have to do some kind of Fenwick tree approach. Now I will explain you that. We are binary searching on the value. Let me show you. I am binary searching on the value of the minimum number of flowers. So the lower bound of the minimum number of flowers will be minimum. Lower bound of the flower is minimum flower. So minimum flower is what? Minimum flower is the minimum flower from the first 0 to I flowers. So let's say I have taken this 5 flowers. So minimum flower will be 1. And what is the maximum value? Let's say target is 15, then the maximum value will be 15 minus 1, which is 14. So we'll iterate from L equals to 1 to R equals to 14, and we'll do binary search on this range. Now we have to check if let's say our mid is 8, current mid is 8, so and we have these 5 flowers. Now we can make all the flowers in these 5 flowers greater than equals to 8 or not. So for that what we have to do? So for that what we have to do, we have to take this sum of these 4 which are less than 8, 1 plus 5 plus 6 plus 7. So 1 plus 5 plus 6 plus 7, and we the number of flowers we need to add is 8 into 4. So we have to check that 32 minus 7 plus 6 13 18 19. So we have 13 flowers or not. So we don't have 13 flowers, we have only 10 flowers. So we'll now, let's say our mid value is now 7. So let's check if it is possible with 7 or not. So 28 minus this value is 7 plus 6 13 18 19. So it is possible. So our answer will be 7. So we'll make all these values 7. So our final array will be 7 7 7 7 9. So how we will calculate the number of flowers less than equals to mid in this range? So for that you can do any of the approach, but I have done Fenwick tree approach. So what I have did is that I have taken one Fenwick tree of, let's say, where every index denotes the number of flowers. 2 Fenwick trees I have taken. The first Fenwick tree will contain the number of flowers, let's say with number of gardens with flowers I. Okay, So let's say 1 2 3 4 5 6 7. So 1 5 6 7. So my first penalty will contain the count and second penalty will contain the sum. So for first penalty it will be 1 1 1 and 1. Okay, and the second penalty or second penalty will contain the sum of i's. Okay, let me do it for you. So this will be 7, this will be 6, this will be 5, and this will be 1. So first I will count all the numbers which are less than 8. So number of ones in less than 8 is 4. So I'll get 4 into target 8 into 4 minus all the sum of all the values less than 8. So it will be, I think, 7 plus 6 19. So the value will be 13. Okay, I think you got it. So when we will do on 7, so number of values less than 7 is 3. So it will be 3 7 into 3 minus 7 into 3 minus all the sum of the values less than 7 here. 6 plus 5 11 minus 2 12. So it is equals to 9. Okay, so it is possible and it is not, because our number of flowers is 10. Okay, so let me show you. So when after iterating on current I am updating on the first bit mask, the count. This is value and this is AI. Okay, this is count and this is value. So you can check the phenolic code here. So after doing it, this is the binary search code. So mid is our mid, and query the number of values less than mid. We'll get it from bitmask phenolic 1, and this is the sum of values which are less than mid. So we will get it from phenolic 2. After that, if our c is less than equal to the number of flowers we have, then the answer is possible. So answer equals to mid, and a is equal to mid plus 1, else r is equal to mid minus 1. So after doing that, so here what I am doing is that current flower is that I have already explained you. So these are the amount of flowers we need to fill the last n minus I number of gardens, and our current flower will be new flower minus number of flowers filled to last n minus I garden, and our current value will be n minus I into fill. So n minus I is the number of complete gardens into full. At the end I am doing c plus equals to bsi comma current flower and minimum number of flowers into partial, and answer equal to maximum answer comma c. And when we iterate over I am updating the first penalty and second penalty. At the end I am returning the answer. I hope you got my explanation and the code. If you have any doubt still, you can ask in the comment section. If you have benefited from the video, please like the video and subscribe to my channel.